That just makes me angry. Hello everyone. Today we're doing something that I've wanted to do for a while. We're watching Season 1, Episode 1 of Mr. Robot. I'm a software developer and I want to check out how accurate they are in terms of the hacking. Hello again. This concept is something I've wanted to do for quite a long time now. It's basically the reason why I've just gone into YouTube. I've been telling my wife I really enjoy watching people who know what they're talking about review things and come up with their insights, whether it be medical or law or computers. So my knowledge is as a software developer, and of course software developers are portrayed all over movie, TV, all that kind of thing. Lots of different ways, some accurate, some not accurate. I've heard Mr. Robot is particularly accurate and I'd love to watch it and critique it to see exactly how true to life it is. Critique it. Now I won't be looking at the storyline per se, but I'll be having a very careful eye on the software side of things and see how accurate it is. Are the hacks real? Can they be done in real life? And the kind of portrayal of software developers in general. And without further ado, let's dive straight in.
What I'm about to tell you is top secret. A conspiracy bigger than all of us. There's a powerful group of people out there that are secretly running the world.
Okay, so first of all, we do have the kind of traditional hoodie-wearing software developer. Now this is something you see over and over again in TV and movies. I'm not surprised, it is quite a kind of cool image, but it's not necessarily a kind of standard software developer. Now, as a group, we're not known to have brilliant social skills and things like that, and we're not necessarily known for dressing well, but it is a little bit of a tired stereotype, but, you know, we'll go with it for now.
Your real name's Rohit Mehta. You changed it to Ron when you bought your first Ron's coffee shop 6 years ago. Now you got 17 of them, with 8 more coming next quarter.
Okay, obviously done this research. If you're going to do kind of a targeted hat, research is always good.
That's when I decided to hack you. Tor networking to keep the servers anonymous. You made it really hard for anyone to see it, but I saw it. The onion routing protocol, it's not as anonymous as you think it is. Whoever's in control of the exit nodes is also in control of the traffic, which makes me the one in control.
So this is the first instance of kind of actual hacking that we've seen. So we've got Tor networking, onion protocol, and exit nodes. So he's thrown a few different sort of technical language in there. All of those are very valid terms. They are accurate things that are used in cybersecurity. So what he's said there is, so this website uses the Tor network to essentially transmit information in a secure way. So the idea of Tor is you can send messages and there's no way of routing it back to whoever sent it. So this person is presumably sending illegal data, whatever form that may be in, and he doesn't want it to be traced back to him. So the Tor networking, essentially, it sends messages through a random kind of array of different nodes. These are kind of host computers, which are kind of volunteers, which act as the Tor network. Now the route it takes is random, and after each level, the onion protocol essentially decrypts it and finds the next link in the chain. So once you get to the last link and you send it to your final destination, as essentially the onion's been peeled off and there's no way of tracing that back to the origin. So he's saying that he is in control of the exit nodes, which is interesting because with Tor, the nodes which you send the message through is essentially random. I don't know how one would control the nodes. I'm a little bit suspicious of the kind of validity of what this hack is. So unless he can control all of the nodes in the Tor chain from the sender to the final destination, and he can essentially decrypt all of those different layers of the onion protocol, I don't believe this is necessarily possible. Mind you, I'll give him the benefit of the doubt because he's Elliot. He can probably use some magic and essentially control the Tor network by sending it through all of his nodes. So we'll go with it. I'm not entirely sure how accurate it is, how practical it is in real life, but you know, we'll go. I think more practically, he's obviously in control of the local network. So once this person sent the information out through the Tor network, that will be extremely difficult to do anything about it. But as he's got local access, then I think there will be no reason to really worry about Tor particularly. If he controls the local network or the exit information of that local network, that's probably where he's intercepting it rather than doing anything external.
Angela, she can be a bit high-strung sometimes, but trust me, she's one of the good ones. What am I looking at? Is this a log file? This was a RUDY attack. This is awesome.
Gideon, will you please answer me?
You think this is awesome? This is killing us, Elliot.
Gideon, I'm not
Angela! Let's just see how this meeting goes today.
Okay, so what looks like is Elliot works at this company, and for the last couple of weeks they've been experiencing a RUDY attack, which is an "Are you dead yet?" attack. So this is one form of a denial of service, where the denial of service is essentially, imagine you had a website, or imagine someone's hosting a website and you don't want anyone else accessing it. You essentially perform something on that site which ties it up and blocks anyone else accessing it. So the concept of an "Are you dead yet?" attack is you're essentially doing a very slow form of attack, long and slow. So you say, you initialize a connection with it and say, oh, I've got a very slow connection, and you send bits of data very slowly, packets of data really slowly, so once every 10 seconds. And the host computer that's hosting the site is having to waiting for these individual packets to come in, slowly building up your message. Like your messages could be anything, but essentially you are tying up one of their connections. So you get a number of these processes going, all of them sending a really slow connection, almost simulating someone who just does have a genuinely slow connection. And the host website is slowly picking them up and keeping the connection open just to host your one of your attack threads. So if you imagine, if you can get a number of these, doesn't have to be many, to tie up all of the connections, then if you're a user who genuinely just wants to access, who has a fine connection, all the connections are taken up and there's no way to actually use the site. So that's why we call it a denial of service, because it prevents anyone else using a particular site. Now, there's a number of defenses against these kind of attacks. One, effectively, is having sort of sophisticated timeouts. So if messages go on too long, then you say, okay, let's cut you there. But of course, the issue is if you generally have customers who do have very slow internet connections, they might look like RUDY attacks. If you do put timers in, you might actually find you block certain valid users, but you do prevent these kind of slow, long, drawn-out attacks. Okay, so also, it looks like they've got their logs printed out on paper, which is kind of weird. I can't imagine ever printing logs out onto paper form. For one, logs are generally not that simple. Usually you've got to do a lot of filtering, a lot of cross-referencing. I can't imagine ever actually printing logs out onto paper. I mean, I would say this scene would be a lot more accurate if they had a tablet or maybe just a laptop they're literally showing around. Yeah, having printed out logs, I would say that falls into something that's done for TV, but not particularly accurate.
You're coming in?
Yeah, what did we say about the dress code? All right, now look.
Okay, so it looks like the customers who have this service that this company is managing are coming in, and there's a little quip there about the dress code. Obviously, developers are not necessarily known for having the best dress sense. Yes, there is very much a distrust of people in suits because they're seen as management, not really technical. This is very much something that is kind of a common theme in the industry, which I would say is not particularly helpful. So I know a lot of sort of consultants who do go and talk to dev teams purposely do kind of dress down just so they're not sort of excluded so much. It's an unfortunate side effect of kind of the view of a developer within the developer community, which is somewhat harmful. So overall, quite accurate. Yeah, overall quite accurate. It's something you might see in an office. I know if a client comes in, I very much dress up, whereas I'm not usually.
Thinking about.
Okay, well, Elliot's having therapy. Good for him.
Her password, Dylan2791. Favorite artist in the year in which she was born backwards.
Okay, so he has gone to therapy, but for whatever reason, he's hacked his therapist. So let's have a little look, see what actually kind of attack he's done. So there's a terminal. Let's bring that up now. Okay, so first things first, this is a terminal, something which you would very much would use for launching a hack. In general, you wouldn't bother coding up kind of a user interface or something like that if you had your own program, which I suspect Elliot probably has made his own hacking program. So yeah, this is somewhat looking pretty cool. This only flashed up once, but we're going to have a bit of a delve in it, see how accurate it is. So what have we got? So right at the top, there's ping of IP address. So this would be however he got it, the IP address of his therapist's computer. So he's done a ping, so there is a connection that he can access through the internet from his computer to his therapist's computer. So it's accessible. Okay, so the next line is this ELPS, Elliot password crack maybe? Essentially, this is his hacking program. Presumably he's written it himself by the looks of it. And he's using a couple of lines here, which is setting up the kind of attack he's doing. So first one is password list add. So it looks like he's doing a dictionary kind of attack. So basically he's adding sort of Dylan, a date, Stonehenge. So whatever these values are, he's picked up from knowledge of his target. He's used them as seed to augment his existing dictionary. So the concept of a dictionary attack is essentially, let's go through all the common passwords that we know. Common password lists are available online. You can download them. If your password's in one of them, I suggest you change your password because it will take sub-seconds to crack. So essentially, he's just going to connect to her computer, try every single password on his list, augmented with some personal values like Dylan and June 3rd and Stonehenge, and hope that one of those are her password. So it looks like the next line, he's configuring in the IP address of his target and a couple of other parameters there. I'm not entirely sure what those are, but essentially setting up his program to perform the attack for him. So essentially he types that in, press enter, and then I suspect the next few lines are the program running. So list count that many. So this will be a password list of a dictionary of all the most common passwords, and then augmented with the seed values he's added, for example, Dylan, Stonehenge, all that kind of thing. The type alphanumeric, which essentially he's allowing letters and numbers. So scanning fleet, time lapse, 24 seconds, I assume, and then it's come out with a password. So one comment here, which actually is not quite so accurate, is once he's run the second Elliot password crack command, I think the next few lines are generated by the program. However, on the left there, there's still the root at Elliot, which is your kind of terminal prompt. So those in theory shouldn't be there. I suspect that just for the sake of having everything nicely aligned and so easy to read by people watching, they've probably added those in. But in theory, they shouldn't be there because that kind of implies that each of those are commands that he's entered, which obviously isn't the case. So small niggle, but looks a little bit different for someone who would actually be doing this in real life.
Creating is insight. Our social media faking is intimacy.
Well, I mean, there certainly is a lot of truth behind that, isn't it? After all, we're all friends here, we can agree. So I can't see exactly what's going on here on his computer, but a bunch of terminals, pretty accurate.
Hi, I just left my keys in one of your cabs. 56Y2. 306 Hawthorne. Thank you.
So this is an example of what you'd call social hacking. Now, social hacking is one of the most common form of hacking out there. The most common being things like phishing, like fake emails and things like that. So Elliot's doing a very much targeted hack to this individual, rather than kind of phishing, which is send out as many things as you can and you'll get a few catches. But one of the most insecure things about any system is the users. So this is where social hacking is, which is the most common form of hacking. You can be all clever with your kind of cryptography and your, breaking through firewalls and things, but social hacking is the most dangerous to any organization or any individual.
Finally.
Calm down. It's only been an hour.
Yeah, well, an hour in Evil Corp's time is like $13 million in revenue, approximately.
Elliot, this is bad. Worst DDoS attack I've ever seen.
Did you reconfigure the DNS?
Okay, so a DDoS or DDoS attack, as she mentioned, that again is a denial of service attack. So instead of the RUDY attack, which was a very much a slow send messages, keep all the connections tied up, a DDoS attack is you get your botnet, get lots of computers, usually kind of like zombie computers, ones that don't know they're part of a botnet, and send loads and loads of messages, completely drown out any messages that can come from valid users. So it's very much the concept of get a lot of people just to shout at the server, and then any actual user trying to get in won't be able to get in because it's just completely flooded. It'll hit their rate limits and most traffic will just be kicked out. So again, a DDoS attack is just a different form of denial of service. It prevents users gaining access. So how one usually does a DDoS attack is you first need to establish some kind of botnet or a collection of compromised computers which you can use as kind of slave computers to send messages from. So if I have, say, a botnet of 100 different computer slaves, then I can say, okay, all of you start sending messages every second to this particular target. And they've got send thousands of messages every second, keep that up for a while, and you completely flood the recipient's computer with messages. It can't process any real users because there's so much noise, so much fake messages that it just gets completely overrun. Now, in general, this doesn't do any sort of actual harm to the target computer, assuming they've got kind of rate limits set up, assuming you've got some fairly sensible precautions. It doesn't damage your system, but it does prevent any valid users actually gaining access to the system. Hence, it's a denial of service attack.
Yes.
Stop the services.
I already stopped the services, tried to reboot the servers, but they're not coming back up. Dude, someone is...
Okay, for whatever reason, these computers are being restarted, so it looks like this DDoS attack is actually crashing servers, which is a bit weird. So your system should be able to stand up on its own, even if it does sort of block messages coming in. I would be surprised that it couldn't start the service, but just say, I'm going to throw all these away. So a DDoS attack, again, doesn't actually damage your system. It just essentially shouts at it, so no general users can be heard. So I think this is maybe a little bit TV rather than real life.
They're in the network.
What's the status update? You see, I thought we set up security protocols so that this doesn't happen.
You can never set up security protocols, so this does not happen. That's not something... You should never say something can't happen when it comes to cybersecurity. That's just not a thing.
Where's the attack coming from?
Everywhere, obviously. USA, Finland, Thailand, Kuwait.
Start restarting this.
So Edit said attack come from everywhere. That's the concept of the DDoS attack. You have lots of a botnet, like lots of compromised computers all sending messages. So yeah, it will be an attack that essentially is from global. You don't know where the person who's sitting at the computer on the other side controlling the botnet, you don't know where that is. But all of the compromised computers sending the DDoS attack are from everywhere.
Services, load sharing, redirect the traffic, and call Prolexic for help.
Okay, so he mentioned load balancing or load sharing. If you have multiple computers which are running whatever service you're running, so if the botnet is not too big, you may be able to deal with all the incoming false messages and also process the genuine user messages as well. But that's very much a size scope thing. Now, I wouldn't be surprised if, as it's a very big company, it's Evil Corp, there's a lot of redundancies in the system. So having some good load balancing, sharing them out across all the different servers, potentially that might help things. And the thing about a DDoS attack is it's not necessarily you're 100% compromised. A DDoS attack it denies service, so it may prevent half the users getting through or a third of the users getting through, depending on how much load it's taking up. So potentially they may be able to increase their capability, scale up all of their infrastructure, and ride out the DDoS attack that way.
I don't think this is just a DDoS attack. I think they got a rootkit sitting inside the servers.
Sorry, it's malicious code that completely takes over their system. It could delete system files, install programs, viruses, worms.
How do we stop it?
That's the thing. It's fundamentally invisible. You can't stop it. All of their servers are timing out. None of them are coming back up.
Okay, so this rootkit is crashing the host. So earlier I mentioned, I'm not sure why the hosts are restarting. That's presumably because this rootkit, like I said, DDoS attack doesn't actually damage your system. In theory, all services should be started. So I suppose the fact that they were coming down and not starting again is very much an indication of the rootkit. So yeah, I understand where Elliot got that from now.
We're putting the network back up. Now, you're downloading the logs, right? Because we...
Stop. Tell them to stop.
What?
Don't start the boot sequence. You guys missed one. There's an infected server up and running. Yes, you got this. You got this.
Now, this is impossible.
So that was a bit of a whirlwind. Give me a sec just to get my thoughts on that. So just as a quick summary of what's gone on there. So there's this rootkit that's spread across the system. They've managed to wipe the rootkit from every computer bar that one in the middle. So that looks like it's kind of acting like a switch for a good chunk of the network. So obviously if that one is a required server, they can't just turn that off. Unfortunately, they didn't have auto switching on, i.e. they couldn't just jump over to the different server. So I guess Elliot had to reconfigure the DNS to point to the different server, reconfigure the traffic that came from all of the servers underneath through to the new server, which essentially allowed that to route error all the connections to the internet. I mean, it's a good job that he's pretty good at terminal, that's all I can say. Now, one might ask, why can't they auto-switch that over simply? It seems like a single point of failure. In computing in general, you should never have single points of failure without some kind of simple mechanism to kind of route around or resolve that. So if I was going to go to a post-meeting about this to pick out the incident and see if there's any way we can resolve it in the future, that's the number one question I would ask. I would say, well, why couldn't we switch this back up simply? Why do we need to fly Elliot over to the data center in order for him to do some elite terminal skills rather than having a simple playbook which allows someone who has the access rights to switch over? So Elliot is very much a single point of failure here along with that server, and that is something which no system should ever have. No single point of failures. Again, look pretty cool for TV. I would say that's something which, if you were a security architect, you would very much be on top of and you'd figure something out. If anything, maybe Elliot slipped up on that one. He should have planned in advance rather than save everything at the last minute.
Take a look at the infected server, okay? Give me a minute.
Yeah. I'll meet you at the elevators.
They must have left a mark or something. Every hacker loves attention. They don't just do DDoS attacks for no reason. This is it. F Society. Is that supposed to be a joke? This note is from me. They're telling me to leave it here. But why? It doesn't matter. Time to shut them down.
Okay, so there's a couple of terminal outputs there. Let's have a quick look at them. So Elliot's found this fsociety00.dat file and a readme.txt file. So firstly, he did a more readme.txt, which essentially just prints out the output to the terminal. That's pretty accurate. And I would actually note here that that's, I believe, him actually running that command. So I mentioned earlier that the text on the left, where we had root to Elliot's, the terminal prompt, shouldn't have been there on the previous terminal. But you can see here, it actually kind of cascaded down and is left aligned. So this is, I believe, genuinely running the command, which is kind of cool. Okay, so he's considering removing this fsociety folder, which was in the root directory, and this contains the data file and the readme.txt. However, the command it uses is /root/space fsociety. Now that command won't work. So there shouldn't be a space between the root slash and the fsociety. I think this is probably the only actual error that I've seen so far in the terminal. I suspect they've done that just to make it so easier to read. It stands out more. Very much something for TV.
I'll reconfigure the access to the root directory so only I can use it. No one will know.
Okay, so he's decided not to delete this folder, and he's done a chmod command, which changes the access rights. So you can see there's sort of 3 digits. There's 600, so that's effectively representing read, write, and execute. So he's allowing reading access, but no writing and executing, which totally makes sense if there's a malicious file in here, because there might be some code in there which you do not want to run, obviously. So yeah, very sensible. So I've just paused there just so we can have a quick summary of what we've seen. So we've seen the RUDY attack and we've seen the DDoS attack. These are relatively low skilled attacks, so you don't necessarily need a huge amount of knowledge to perform them. So they're both denial of service attacks, which aims at denying access to genuine users to some kind of network or service by sending messages in different kind of configurations, which disrupts the ability to that server from processing any valid requests. We've also seen the concept of the rootkit, which is something which is a lot more highly skilled. So the rootkit is different from the other two attacks because this is an attack that actually gets onto the server. You actually put code onto the target computer, and it'll be very interesting to know how that's done.
The rule here is it's done here and only here. It ends when you walk out that door and begins when you walk in. Our encryption is the real world.
How do you talk to each other then?
We don't. We come and go, work on the project when we can.
Okay, so they're talking about doing all of their activity in person within this particular one room. So I think it's probably not a bad time to mention the concept of an attack surface. So if you have lots of different dependencies, lots of different positions, lots of different points of failure, that increases your overall attack surface. And the idea of security is to have as few dependencies as possible, have a few different points of access, try and reduce the attack surface so there's only a few places that you need to keep strong. You can only know about and secure a certain amount before just the complexity gets too much, and every single dependency you pull in is another possible attack vector. Especially with modern software, when we do have lots of dependencies, we do pull in lots of code from other users. It is very difficult to control your overall attack surface. The only thing you can do is to keep all your software updated, and also to pull in as little dependencies as possible. Now they're talking about very much dependencies of people, being spread out, lots of different, using different technologies to communicate, all that kind of thing. Everything you add adds an extra vector of attack, which someone can exploit or you can be discovered by. So the concept of doing everything locally, trying to have as little kind of working parts going as possible, reduces your attack surface, makes everything a bit more secure. So yeah, it's sensible.
Watch your favorite movie?
Back to the Future 2. Not as good as the original, but not a bad choice.
So, what do we got?
So, if you'll take a look at the first page of your agenda.
You're the one who stopped the hack. The gals in analysis said this was a tough one, all things being equal. Should have shut us down for days, so you did good.
Okay, they're very sensibly having a meeting to discuss the attack, presumably to tighten up security and prevent things like happening in the future. So whenever you have an incident, it's always best to have kind of a retrospective afterwards, especially around security, to deal with, is there anything we can do better next time? And it's very crucial in these kind of situations to not have any blame, because if you have any kind of blame culture, then people are less likely to come up and say, well, I did this, which compromised us. So remember, never view these meetings as something which you need to find a scapegoat for, never something you need to find whose fault it is, because that just does not help. You need to have a blameless meeting where people can come up honestly and say what actions they took, what actions they probably should have taken, and that's the only way to constructively have these kind of things. Remember that.
Anyway, he arrived at the office at 2:35, and I instructed...
Okay, wait. So that's almost a half hour after the initial breach. Why didn't anyone pipe in from their laptops?
It's not...
It wouldn't have been secure if someone terminaled in on this. It was a smarter move to have someone come in so they can log in on a secure line.
Exactly. Then Lloyd was able to info by Lloyd...
Actually, just 1 second. Now that that's taken care of, let's pick it up where we left off.
What happened to Angela? She knows more about what happened.
She's not going to work out for us. Not on this level. We need to stick to the more tech savvy here.
Okay, so they've just kicked out one of the people who was managing the situation because she's not technical and perceived to have making mistakes. No, she has probably a very good view of what happened overall in the situation. She was the one who was aware of how much revenue lost. She was aware of what happened with the kind of external. She was checking out the external viewpoint. And they've just kicked her out of the meeting, which completely removes the viewpoint of someone who was managing the situation, who could have very good insights on how It's not necessarily done everything perfect, but should not be blamed for the actions they took, because she did the right thing. She called Elliot. She made sure that whoever needed to be there was there as quickly as possible. And discussing that, saying maybe we should have some kind of contingency or something around that. But like, her insight is valuable in making sure that this incident doesn't happen again. Throwing away expertise just because they're perceived to have made a mistake is just a ridiculous thing to do. Yeah, this makes me angry. Okay, he's saying stick to the more tech savvy. Well, no, it's not just the technical people that are involved in something like that. You have process, you have management, all these kind of things all come together. They are all just equally important for security than, you know, the person who actually kind of did the final kind of keystrokes to resolve it. Any particular kind of incident can be protected, can be prevented at any level. So you kind of have the concept of kind of a mesh. And if you have an attack or like an incident that goes through the entire mesh, then that's when things happen that are an issue. However, if you can put more meshes up that kind of blocks any particular kind of avenue of attack, then that's a good thing. You do not just want one kind of, you know, idiot at the end and remove everything else. You want every single layer as strong as you can, and they all work together. And you know what? Elliot wasn't in the office. He was, you know, he was taking his personal time. He can do that. He got into the office pretty quickly in his own personal time. I don't know what anyone would have expected to happen. I mean, it does sound like he's maybe the point of failure. He seems to be the only one that can kind of deal with that situation, which is an issue. They probably do need some, well, for a start, they need some more security people and some skill share, if anything, or some processes which other people in the office can kick off. Yeah, I mean, as a company who is managing the security, they are definitely not doing a very good job of it. They've got one coding superstar, which solves the issue, and that kind of view of the one coder that can solve every issue is something which is quite prevalent in software developing cycles, but it's something which is quite harmful. No, software development is done by a team, not by any individual. If any individual is the single point of failure of any development team, that is an issue. That is something you need to address. You need to be proactive about addressing that, and getting rid of the people who were there, who contributed to the situation but didn't necessarily do the kind of final keystrokes like Elliot did, is, yeah, that just makes me angry.
Department. Unfortunately, I have to inform you that your account's been compromised.
What? What happened?
First, before I can answer any questions, I need to verify some information. Are you still at 306 Hawthorne Avenue?
Yes, apartment 2C.
Great. And your security question, favorite baseball team?
Yankees. I don't remember this being a security
question. And lastly, your pet's name?
Flipper. Who am I speaking to? Can I get your name and number?
With those details plus a dictionary brute force attack, it'll take my program maybe 2 minutes to crack his password.
Okay, so this is very much the one practical thing that I would say as a takeaway to if you watch this video to this point. So Elliot's just phoned up this person and has asked them a number of security questions, basically with an aim to gather a little bit of information about them. So if anyone ever phones you and they're asking personal questions about you, it's not on you to verify your identity. Even if they say they're your bank, for example, what you should do is say, okay, well, let me hang up and I'll call back on the kind of verified number from your website. No one should be worried about you doing that. If you get an incoming call, you cannot verify who's making that call. In this case, it's Elliot making the call, pretending to be the bank. Even if it looks like the ID is from the bank, you shouldn't give out any of your personal information. Now, this is something which is incredibly common. However, it's very easy to combat if you're just a little bit kind of aware that this is a thing. So if you ever get an email or a telephone call asking for your information, then one, don't give it to them straight away. And if it's something you might want to act on, like if you're a bank, you say, okay, well, this is something I do want to act on. I will call you back, but I will make the phone call. Therefore, you know that you are the one. You can verify who you're talking to. You know you're talking to the official number, and it's not some random person that's just spoofed the kind of the phone number. No matter how fancy all this kind of password cracking and encryption, all this kind of thing in the show, the biggest form of hacking is things like phishing. It's social attacks, and the best defense is just a little bit of knowledge. That's all you need. Just be a little bit aware, and if you're not sure, just ask someone.
Bonsoir, Elliot.
Please tell me you're seeing this too.
And what an ending. That was fun. So I'm going to give this a quick summary of how I thought it was in terms of the technical perspectives of someone who does work with code. So I thought overall it was pretty good. They had some good examples of hacking. So they had things like external attacks, denial of service attacks like DDoS. They had things actually getting to the root system. They had some good terminal action, and they also had some social hacking, which I'm really glad to see. It wasn't just type. So that was really good to see. Overall, I think the terms used and how they described it were very accurate. If I'm being very, very pedantic, there was that one issue with the terminal, a couple of issues with terminal, one with formatting, one command actually just wouldn't work, but I'm going to let that slide because I understand why they would do that. Right back at the beginning, there was a little bit about the Tor network, a little bit dubious about that. So funny enough, the thing that I thought was most lacking accuracy was not necessarily the technical side, was very much the kind of process side. And any large company who are really focused on security doesn't come to the table with a genuine want to find out how they can improve the process rather than just finding out who was to blame. I think that's actually something which is somewhat archaic. Obviously works well on the TV show, but I think that's probably the thing that let it down. So overall, I was very impressed with it. I thought it was a good episode. I enjoyed watching it just as a ready consumer. As a developer, I thought it was bang on. I thought it was entertaining to watch. And yeah, overall, from the technical perspective, I'm going to give it a solid 9 out of 10. And that's that. Dev watches Season 1, Episode 1 of Mr. Robot. If there's any other things that you think I should have a look at, then please let me know in the comments. Like and subscribe, all that usual YouTube stuff. And I hope to find you watching the next video. Thanks, everyone.